In the last video, we were exposed to the general transformation model, and we saw some things happen through Desmos. It was kind of fun. Now we want to kind of dig in and see, okay, what do each one of these do exactly? We have some idea, but now let's formalize it. All right. So we're going to begin with C and D, investigating those, just because their addition, it's adding things is generally easier than multiplying things, maybe. So we're just going to begin there. And to begin, we're going to look at the function f of x is equal to x squared and describe what is happening if we do f of x and then all plus 3 using a tabular, graphical, and descriptive approaches. Okay, so we might remember that, if we have x and then f of x, which is equal to x squared, that we had our base table as -2, -1, 0, 1, and 2, and then the f of x values, the y values, again, this is just a fancy way of saying y, is 4, 1, 0, 1, 4. Okay, fine. Okay, now I want to imagine, what if I added another column in my table that was f of x plus 3? Well, this is just saying take the y value and add 3. Oh, okay, so take the y value that I have and add 3 to it. 7, 4, 3, 4, 7. Okay. And so if I wanted to do that, right, let's just maybe make a little sketch here. Okay, so um, we have 1, 2, 3, 4, 5, 6, 7. Okay, that's how high I need to go out each direction. I need to go 2. Okay, make that a little wider so it's easier to graph. My base function would look like this. 0, da, 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 da. We can do this in our sleep now because we have committed these things to memory, but we have not memorized them. We've got a lot of practice. Okay, so here is f of x is equal to x squared. Okay, now what I did with the transformation is, right, I just took f of x, the y values, and added 3. So actually the y values changed, right? But the x values remain the same. So now I'm just plotting the point, say -2, 7, -1, 4, 0, 3, 3, and here we go. Something like that. All right, so something like this, and this is f of x is plus 3. Okay, so what was the effect? Okay, it went up by 3 units. Okay, fine. Descriptive representation is done. So, up 3 units. Okay, and what if it was -3? Well, that would probably go down 3 units. Okay, and you could do it with a table as well. Okay, we're just not going to. Okay, so what does D do in the general transformation model? The language that we use for it is a vertical shift by D units, and then we kind of split it into cases. Up if D is positive, and down if D is negative. Oh, okay, that's fine. Great. One of the 4 is already done. Let's talk about the next one, on to C. Okay, what about this one? So we're going to change our base function and change it to just square root of x. So again, if you need to imagine the base table, so f of x is square root of x, and again, this is just the y value, so we have 0, 1, 4, and 9, and with that we said we had the points, or the y value 0, 2, no, 0, 1, 2, and 3. Okay. Now we want to know what x plus 2 is. Okay. Now here's the tricky thing with doing the plus 2 on the inside with x. Okay. What we're doing is we're saying that this x, okay, so we're looking at this particular point, but we're looking primarily at this 0. Okay, and what we're doing is we're going to replace that 0 by x plus 2. Okay, so x plus 2 is now the same as 0. So then if I were to solve this, right, x is subtract 2 from both sides, x is -2. Okay, so now I have a different x value, which is the x value x plus 2. And so if my original x was 0, that means my new x is minus 2. Okay? Doing that again, because it's a little weird. Okay, if I look at this point, I would take the x value from that and say, okay, well, it was 1, but now I'm replacing it with x plus 2. So then if I solve, I get x is equal to minus 1. Okay, so my new x value after I do the x plus 2 is minus 1. One more time, and then maybe we'll detect the pattern. Okay, and then next point, I'm going to pick the x value. So the x value was 4, but now I'm replacing it with x plus 2. Solving it, the new x that I have after this transformation has occurred is 2. Okay. All right, can we detect the pattern? Maybe, hopefully. So 0 moved to minus 2, 1 moved to minus 1, 4 moved to 2, and I think we can say that 9 would move to 7. It moves 2 units to the left. Okay, so we can see this, or I guess graphically what we would see is the following. So again, just making some ticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I need to go 3 vertically. 1, 2, 3. Okay, here's my base graph. 0, 1, 4, 2, 9, 3. Okay, there is my square root of x function. Okay, and then now I have the point negative 2 comma 0. Okay, negative 1 comma 1. And then let's see here, and then over here. Okay, so here would be my new function. That would be f of x plus 2. And again, we know how to do this. This is square root of x plus 2. Okay, I take x and replace it with x plus 2. Shifted left 2 units. Okay, and so what if it was to the right? That could be a little interesting to work through, but if you wanted to imagine, 0 is now equal to x plus 2, or x minus 2, x is equal to 2, okay? So 0 shifted to positive 2, that would be to the right, okay? So what does C in our general transformation model do? It is a horizontal shift. Okay, horizontal because it's changing x. Okay, so this is an x horizontal shift. And then we have, again, kind of 2 cases. Right down here, I've kind of summarized everything that we've talked about. We talk about D as a vertical shift, vertical translation, tomato, tomato. And then C is a horizontal transformation, shift, same thing, left and right according to their values. Okay, so we'll investigate A and B next.